Hello, everyone. Welcome to the fifth and the last edition of the five presentations that we have been actually doing for our book, Effective Platform Engineering. So in this session that we are actually going to be talking about is something that is very different from the first four sessions that we talked about. Here we are actually going to look ahead. We're going to start looking at what are the impact of GenAI and LLMs in platform engineering. So this is not about GenAI or LLMs per se, but how is that being applied in the platform engineering space? The format of this presentation is also going to be slightly different. I'll be showing a lot of different tools that are relevant today. That doesn't mean that it'll be relevant, a month down the road or 6 months down the road, but those are relevant from the platform engineering point of view. Hello, everyone. You are now watching the fifth video in our five-part series introducing the new book, Effective Platform Engineering. So far, we have done 4 videos. So the first video is where we explained what platform engineering is all about and why it's become such a game changer in the modern software industry. So in the second video, we talked about technical product management and showed how it sort of acts as the backbone or the pillar of the overall platform strategy. In the third video, Brian Oliver talked about this really interesting concept of compliance at the point of change, a shift in that mindset that really helps the teams become much faster and safer in their overall platform delivery. Fourth video is unique in the sense that Sean Alvarez showed you, some of the code examples that we are used in the book as part of building an engineering platform. So these examples, I believe, has really introduced you to some of the real intricacies of how to actually build an engineering platform. So if you haven't seen those videos yet, we really recommend that you watch them first. The links are below. They'll also give you a full picture of what we are actually going to be talking about today, which is on the GenAI side of things. Thank you. So the kind of things that we'll be covering today is that we'll start with the context of AI in platform engineering, and then we'll start talking about some of the measurement aspects, because we are not just talking about GenAI and how GenAI is helping software engineering, right? As a software developer, you are all using, some of the tools that are out there. The focus here is not going to be all of that, but it's specifically about platform engineering. Then we'll talk about how do you actually baseline some of the developer experience activities that we have been talking about for the past few videos, and then talk about how to improve that using GenAI. Then we'll specifically get into a couple of areas, from the point of view of the demos. We'll be talking about some of the operational aspects of software delivery. We'll be talking about some of the observability aspects and how all those things are really helped by what we are seeing in the GenAI advances. Finally, we will conclude by a few Agentic AI examples and demos. Again, these are demos that you can actually go in and see from outside from some of the tools that are out there. So we have specifically set up this presentation in such a way that you don't really have to buy anything, you don't have to build anything to learn it, but we will actually use some practical examples and the tools that are out there. So with that said, we'll talk about how we are actually going to cover this. So like I talked about a little bit earlier, so we'll talk about some of the key concepts, then we'll look at the tools landscape. Across the board, we'll be looking at a lot of different tools. Some of the tools we'll be actually diving a little bit deeper. That doesn't mean that we are actually going to be teaching you about those tools. We just give you an overview of how those tools will work. So we'll switch back and forth between this deck or the presentation, and then we'll talk about some of the concepts there, and then we'll cover the tools and then come back to this. So to start with, we should baseline this. So let's think about from the point of view of what is the context of AI in platform engineering. So it's important for us to understand that before we start looking at the details. So augmenting platform engineering with AI, is to essentially to create that self-healing adaptive platform that improves your developer experience, right? So this activity also happens a lot more autonomously today compared to how it was 6 months back. When we first started writing this book, obviously that autonomous applications of GenAI or the agentic approach, like we call it today, wasn't as prevalent as it is today. So right now, the industry and the market is being exploded with tools that can actually do a lot of things that will improve the developer experience from a platform engineering point of view. So one thing you should be really thinking about is that how has this evolution of AI in platform engineering happened? So we know that years back, we are all focusing on the do-it-yourself DevOps. Essentially, there'll be like a problem that needs to solve, and then we would end up solving those problems using some level of automation, some level of manual intervention, which sort of evolved into this idea of IDPs, right? Some kind of standardized IDPs. So these are those back-end orchestration that we could do that will make sure that the overall process is far more efficient from as a platform engineer. So the developers who are actually consuming those products or the capabilities that you produce as a platform engineer becomes more self-sufficient. So that self-sufficiency started getting augmented with AI, right? I mean, so that is something that we've been seeing for the past few years, that augmentation was there. So there were, and we'll look at some examples like that today. The kind of activities the developers were doing were continuing to be improved and more productive. Developers became more productive. So finally, we have reached this point of agentic platform. So this is a double-edged sword, right? Because if you really let the agents do the things that you want your developers to do, or whatever the developers want to do, from one point of view, it's pretty good, right? Because the developers don't have to learn anything. They can just push a button, or they can actually let their systems, their pipelines run the way it is, and then your AI would go in and figure out the challenges in the pipeline, go out and fix everything, and make sure that all the data is automatically available. Now the problem is the amount of visibility that you would have into whatever is happening within your engineering platform space has completely come down. This is very similar to somebody using automated code gen, using Cursor or Claude or any of those kinds of models that you have there. You end up, creating a bunch of code, but as a developer, the question really is that do they really understand what is actually happening, what has been generated, right? If it is, I mean, you might say that why do developers need to know, right? I mean, yeah, there are still a lot of reasons why the developers need to know what kind of code has been generated. So there are, challenges around similar to that within the platform engineering space too. Now, one thing that I want to call your attention, so I talked about like, we will, refer back to some of the industry standards and the research and everything that is out there. I'm sure all of you are familiar with ThoughtWorks. All four of us, the authors of this book, has been ThoughtWorks employees at some point or the other. Currently, Brian Oliver and Nick Chenoweth, two of the others, are still with ThoughtWorks, whereas myself and Sean have moved on to other places. ThoughtWorks has been doing something called Tech Radar for many, many years, and I believe since 2010. If you have not really looked up on what a Tech Radar is, you might want to go into ThoughtWorks website and take a look at that. This is essentially an idea where you will have a bunch of experts, the industry experts come together and really look at what is the technology trends, the tools, process, technologies and the process that is happening that is evolving in the industry. And then they look at it and say, how is that being used by ThoughtWorks clients? So that is the approach that they have been doing for the Tech Radar. So Brian Oliver currently is part of the Tech Radar team at ThoughtWorks. So one of the things that he has sort of come up with together with his colleagues at ThoughtWorks is this idea of what are the key themes within AI or the platform engineering space that is being impacted? So as you can see, there are a lot of this IDE, the agentic coding tools that are built in as part of the IDE. Things like most popular ones are Cursor and Windsurf. But of course, Cloud Code is very, very powerful, as well as Client. I mean, there are a lot of different tools that are out there. So I think some of these tools are definitely helping not just the code generation part of it, but beyond that from a platform engineering point of view. Another thing I mentioned earlier was the observability space. So this is a space that is ripe for all kinds of automated improvements that an organization would need to ensure that there is higher levels of efficiency. There is some significant activities that the ThoughtWorks has been seeing in this. RAG continues to remain a central part of GenAI workflows. Now there is now a lot more conversations around, is RAG dead with MCPs and things like that, which is probably outside the scope of this particular discussion. But we believe that RAGs are still going to be relevant within the platform engineering space. So I think one of the key things to think about is that the focus is sort of shifting from the raw volume to more of that rich unstructured data management. So if you have there is no dearth of unstructured data out there. And how do you actually manage that? And how do you ensure that those things are being used by some of those AI-ready systems are a huge thing to think about. So let's think about what is that change in the developer landscape, right? Before we dig deeper into the platform engineering space. The way we would look at that is that developers' role is potentially becoming a lot more of that supervisory role. Again, this is not a done deal, right? I mean, most of the developers are still operating and using the tools and doing things, but you can see that shift happening in industry, right? So the things that used to be a lot more reactive are now becoming a lot more proactive. Some of the generic activities are now more personalized, right? So, for example, if you are using certain tools and if you're if AI is specifically telling you to do things in certain way, depending on your persona, you would actually find that things can be a lot more specific as opposed to being generic there. And fundamentally what that means is that a lot more of those inferred activities are becoming autonomous activities. So how is this evolution happening, right? I mean, I think the way to think about is that in a new AI augmented workflow, you will essentially have those reactive and manual activities becoming more proactive and automated. And the word that we would actually introduce, if you have not heard about it already, is this idea of self-evolving. Within the platform engineering space, one thing that we have been talking about a lot is self-serve, right? And so developer experience would become better if the developers can be self-sufficient to be able to do things. Now this is that next frontier, right? So you're really thinking about it from the point of view of, are these systems going to be more self-evolving as opposed to self-sufficient? Now, we will also show some illustrations from the draft of the book for you to sort of, again, you can definitely go back to the book and refer to this. So in chapter 11, we are talking about the scope of AI in platform engineering. This is important to understand. Otherwise, we might actually just muddle the whole thing and end up calling everything platform engineering with respect to what is happening in AI, or nothing plus platform engineering in AI. So we are trying to make sure that we are clearly looking at it from the point of view what the scope of it is. So as you can see, if you look at the overall life cycle of it, there are various places where you would actually be using platform engineering, and applying AI in platform engineering. So you can see that here, and this is described in a lot more detail in the book. So we would definitely urge you to go and check the book out, and the discount codes for the book are in the description below. So now let's really take a step back again, look at it and from the point of view, what is that hype that we are seeing in the Gen AI, right? You might be hearing all kinds of terms, the wipe coding and Devin and Cursor and all that. So it's important for you to know what that is. It may not be important for you to be an expert at all of these things, but there are a few things that you should definitely pay attention to. So wipe coding is something that is getting a lot more attention these days. This is where you are really not coding using the programming languages, right? You are essentially using that natural language prompts to generate code. So if you go to Claude, for example, and ask Claude to generate some automated scripts, or even if you're developing a website or something, you don't want to really mess around with the CSS and all that, you could just go in and tell Claude to say, hey, generate some of these CSS for me or whatever for me, right? I mean, then it can definitely do that. Similarly, on the platform engineering space, if you are developing some software and you want to make sure that it is actually, you're setting up a pipeline with whatever pipeline tools that you have, you can actually you can go to any of the LLMs and really ask them to actually ask it to go ahead and develop those things for you. This sort of, at some level reduces the need for having a separate platform to be able to do the kind of work you're doing. But the obvious question that you're going to ask now is like, oh, does that mean that platform engineering is dead, right? You're going to just have all the platform engineering capabilities going to be built out of your LLMs? The answer to that is absolutely no. I mean, at least today, absolutely no. Mainly because there is so much of context around all of these things, right? And the other challenge is that the scope of the platform itself, which I think we are discussing a lot in the presentations 1 and 2, you might want to go back and listen to those videos. It's important for you to really see that there is no one platform, no one engineering platform that says, "Hey, this is what should be done. This is how it is." Right? It'll be very different based on your context and your organization. So until and unless you have like a standard platform you can go out buy, if there is a company who's selling an engineering platform that everybody could use, sure, it could be replaced, but that's not what we are really talking about. And we'll get into that with some very specific examples down the road. Hey, if you're finding these videos valuable, we would really recommend that you actually check out the whole book. The Effective Platform Engineering from Manning Publications goes way beyond some of the highlights that we are talking about here, especially things like what we are talking about today on the Gen AI side of things. Inside, you'll find things like real-world patterns and anti-patterns. You would find hands-on examples and code snippets, something similar to what we introduced in video 4. And then we'll find some really good case studies from teams tackling real-world platforms at scale. Actually, we are talking about a company which we are actually calling Epitech within that particular book. And across the whole book, we'll be talking about what Epitech does as part of learning how to build an engineering platform and builds it. So we even break it down on how to scale internal platforms without really slowing the teams down, and how to measure the developer experience improvements in ways that actually move the needle. So you should check out the link in the description. There is also a special discount code for you for all the viewers of this channel. So you should go and grab a copy today and dig in. Thank you. So, but one thing that has sort of evolved, right? I mean, think about it from the point of view, what are those developer pain points, and how has that sort of evolved between pre-platform engineering age to platform engineering and AI-augmented platforms? So it's important for you to really look at it and say that, okay, here are the tooling improvements, here are the operational improvements and feedback improvements and all that. I'm not going to read through all of these things, but it's important for you to understand that each of the aspects that we have in column A, or the column 1 there, has been sort of evolving. The maturity and the convenience for the developers to be able to do things better has happened. So to answer the question from the previous slide, whether some of these LLMs are going to completely replace existing platforms, the answer is absolutely no, and this is where it's proven, right? I mean, so you're seeing that, yes, there's within platform engineering, if you take the cognitive load side of things, yeah, there is still the medium level of cognitive load because you have some golden paths available, so you're not going to make mistakes, but you still need to know what that is. But when it comes to AI augmented platforms, what you're really seeing is that those agents are in there that can actually do some of those things, but you still need to have a human in the loop to ensure that these things are working the right way. It is working. And that is also highly contextual, right? Because in some cases, that human in the loop activity that you might be doing would be far more compared to some other activities. So now let's first look at this tools landscape, because one thing that I personally get overwhelmed, I'm sure many of you do too, is the number of tools and the systems that are out there, and which makes it so difficult for us to keep track of the advances, right? So one thing that I tend to do is that I follow this site called AI Native Dev. If you have not seen that, definitely go check it out, and you can say ainativedev.io. So what this provides is, this is put together by Patrick Dubois and his a group of engineers working with him. The idea is that this is that collection of pretty much all the different tools that are coming up within the AI ecosystem for development activities. So that when I say development, it's all these DLC activities. What they have also done is a great job really trying to make sure that this is actually categorized across product design, the no-code systems, the prototyping, the coding aspects, migration prompting. I mean, there's so many different tagging that they have that shows various tools that you could use, you could try out for the activities that you want to do. So you can see things for the development, then you have a complete section for the QA, and then you have a section for DevOps, DevSecOps, and so on. So some of the tools that we will talk about today are probably here, and which are sort of in the space of platform engineering, right? So one of the things we'll be talking about is this Pulumi Copilot. So if you haven't used Pulumi, definitely check out Pulumi. This is one of the think of it like an alternative for Terraform, but that actually it helps with the infrastructure as code activities. And there is a Copilot Pulumi puts together, and we will take a look at how that works. Similarly, you might find certain, you might have heard of other tools like Kubia, for example. This is sort of like a Slack-based or a prompt-based operations management for activities that you could do to improve your DevOps cycles. Um, and then you might have definitely heard of things like DX, I'm assuming. So these are tools that are essentially saying that what's the better way for us to do the automated observability aspects and things like that. So similarly, you would find a lot more of the tools here, and we would urge you to definitely take a look at this one and familiarize yourself with what interests you, right? You obviously can't be an expert at all of these things, but at the same time, if there is a very specific need and you want to know like how some of these, how AI is impacting any of these areas that we are talking about, this is a place for you to come and take a look at. So having said that, let's quickly move on to the next topic. One other thing, I think this is something that the reason I'm calling this out right now in this part of the presentation is that you've probably seen this study. If you have not, we would urge you to take a look at that. So Meter is essentially an organization that actually talks about, and it does a lot of research and lots of data collection and comes out with all these reports around this, right? So let's look at what happened in this July 2025 report of Meter. You can see that one of the things that they talked about is that both experts and developers completely overestimate the usefulness of AI on developer productivity. So this is something that you would want to know when you're really thinking about AI in platform engineering, right? If you're really trying to use platform engineering to improve the developer's experience, you need to know why this study has come up with that. And there are various reasons, and I would also want you to take a look at the study done by GetDX analyzing this report. But the key aspects are fairly obvious. So here are the things like here are the six reasons or the five reasons why they believe no, AI is actually slowing down the development as opposed to improving it. So one is that over optimism about AI usefulness. Any of you who have used any kind of LLMs to do any kind of code generation or any kind of activities around it, even if it is Copilot, right? You would find that it does not always work as advertised. Meaning, sometimes the code it provides you is not good quality. It makes mistakes. Sometimes because of the fact that if you over rely on some of those things, you might end up wasting time trying to debug those things. So again, it depends on the type of developers, right? If I'm an entry level engineer, I'm not familiar with how to actually do anything beyond the fundamentals of software. I might actually be, in a beneficial state in saying that I can generate a lot of code, I can get something to work, then start troubleshooting from that point on. But understand the fact that not all software developers are entry level engineers, right? These are developers who have been building software for many years, or either in the 5 to 10 years or more. So for those people, they have some idea of what are the kind of product features that they want to build, how are they going to build it. They built up some experience around it. Now, when you're applying some of these models, what's happening is that it's going to generate a lot of code. If you haven't done it, definitely try it out. It's going to generate a lot of code, right? So the amount of code that actually gets generated would need to be tested, and it can actually models can generate the test suites too. I mean, so great, right? So it does all of that, but still, if there is no human in the loop to validate it and ensure that it works, whatever you're producing there is not good enough, right? It's going to have problems with respect to your overall productivity. The other aspects there is like complex repositories, right? So if you end up generating a lot of this code, what happens is that you will end up creating significant amounts of code, right? So and especially if you're trying to refactor some code base that's been around for 10 years, which is a natural thing, right? Or I'm sure many of you listeners might find that the kind of repositories that people are dealing with have like millions of lines of code and tens of years, 10 plus years of life too, right? So I think across the board, when you really look at these factors, they find that because of these factors, the overall productivity of development is actually coming down because of AI. Uh, this is a sort of like a data they have collected over significant amounts of people and organizations and all that. So we should really give it some grace in the sense that it may not be true for everybody, right? There's always going to be somebody who's going to be more productive by using AI, but developers will be more productive. And there are ways in which we will actually look at some tools that actually shows you like how and why that is possible, and how to measure that, and how to improve that in some cases. But most of the news you get these days are skewed to one or the other, right? Meaning, like, you might find that people are saying, "Hey, this is great. It's phenomenal. It's doing all the things I want to." Or you might find people on the other side who might saying that, "Oh, this is crap. This is nothing is working. This is just a waste of time." Right? So reality is somewhere in between, and that is the reason why we wanted to actually show you this study before we go further. Now, moving on to the next section, let's talk about measuring improvements in platform engineering through AI methodology. So this is where we are really, we always talk about this, right? Start with baseline as to where you are from your developer, productivity or the developer experience. Then try and improve that, and then measure it again, right? So baseline, improve, measure, right? So let's start with that measuring aspects of it. So evolving metrics with AI platform engineering, there is a lot of work happening in DORA. So between DORA space metrics, I'm sure you're already seeing that if you're taking some of the DORA surveys and all that, you'd be seeing that there is significantly more focus on the AI aspects of developer productivity improvements and developer experience improvement that is coming out of DORA. So that is something that you might want to look at. So using AI and ML to correlate productivity signals with operational data is something that is happening across the board. There are lots of tools. And again, if you look at a couple of tools, I mean, there are a lot of tools that is actually doing this. But you might also find that some of those AI-based time series clustering, which means that, how do you actually find, if you have a production system, how do you find the specific sets of problems within that system, and how do you actually try and improve that? All those things are happening. And predictive analytics has been one of the key areas where things have worked well. So we should really want to, continue to look at what are the ways in which we can actually do that. Lastly, but not least, I also want to call out the aspects of flow engineering, because as you're really trying to improve what is happening within the platform engineering space by the advent of AI, you don't really want to go in and apply AI wherever that's available, right? Because your problems may not be solved by a tool or a set of tools that is provided in the category. You might want to apply something like a value stream mapping, and then apply flow engineering on top of it, which gives value stream mapping a lot more relevance and context in the area that you are doing things, where you'd be looking at things like outcome mapping, what is your current state, what is your future state, and how does it all come together. So I think you might also want to look at the flow engineering aspects before you really figure out how do you baseline this. So AI-powered measurement techniques are very powerful today, and it really works. And it's things like, if you're trying to measure certain things, right, you're going to have measurement both from the point of view of quantitative and qualitative side of things. And we are discussing some of these things in the book itself. So having some of those feedback loops or embedded using AI agents would be far more effective than not having that, right? Because that makes sure that your level of responses and the quality of responses would be far better. And some of the RAG pipelines can help summarize some of that platform telemetry, because sometimes the amount of telemetry that you can generate by instrumenting your pipelines and instrumenting your overall engineering platform is very high. So having those RAG pipelines can help. The other thing that we are seeing across the board, across every client that I work with, what is that the relevance of those NLP techniques to analyze developer tickets, platform documentation, and all that, right? So there are places where we know that, in one of the previous clients I work with, they have pretty much all their problems in their Slack with respect to people asking questions and people responding and all that. So in the past, it used to be far more difficult for us to really figure out patterns from it, right? I mean, so you need to really go through that and figure out manually and write automation, all that. Because right now, with some of the NLP techniques, it's easy for us to go in and look at some of these threads and quickly figure out what are the patterns of friction, how do you actually improve some of those things. and using some of the reinforcement learning models that simulates policy impact and performance, meaning like if you have a golden path, can you ensure that that golden path is working well, and how do you actually improve that? This is another reference from our book. One of the things that we typically ask people to do is that look at, as you're really looking at the overall life cycle, look at it from the point of view of what is that overall AI-driven SDLC, and what are the specific things that you would need within those steps. So, for example, if you're looking at this one, and if you have done some level of flow engineering activities, you might find that what you need is not everything, right? What you might need is some improvements around the observability side of things that will actually improve your overall efficiency of how you're actually getting things done, and your overall developer experience will be improving. So make sure that you do that flow engineering we talked about in the previous slide, and then come back and look at it and say that, hey, this is where I want to focus on. Otherwise, just like you saw that plethora of tools in that AI native dev website, you are going to be overwhelmed with the amount of tools and the services and techniques that's available today. Excuse me. So let's also look at a metrics of metrics, right? So for example, if you're looking at it from the point of view of what is that traditional metric that you're really looking at, and what are those AI-augmented signals, and how AI would add value? This is something that we would want you to look at it from the point of view of, maybe let's start with DORA, right? So we have the 4 DORA metrics, which are basically lead time for changes, your deployment frequency, change failure rate, or MTTR. For each of that, look at it from the point of view of what is your AI-augmented signal there, and you can actually come up with your own signals there. But here is a good set of examples, and then think about it from how AI adds value to this, right? So if you are able to figure out that signals through AI, then you can really figure out how can AI add value to each of those things. Let's take, for example, the MTTR part of it. So, if that's a traditional DevOps metrics that everybody uses from DORA point of view. So your signal there could be like, your latency in the RCA. So for example, you're trying to figure out why did something happen, and that has been, very, low in the past. Now with some of the AI techniques, you are able to sort of improve that. So if you have that LLM assisted RC and root cause suggestions, that can really speed up things. Because if you look at most organizations, um, the amount of blameless postmortems that they do, and the amount of RCA actions that they generate are really, really low, right? I mean, so if you work for an organization where that is working great, that's phenomenal, because most organizations don't have that. So these kinds of techniques can be further enhanced by using some of the AI, using the LLMs and some of the AI tools. Now, you shouldn't just confine yourself to DORA in most of these cases, and so definitely in this case too, right? So looking at it at some of the other leading and lagging indicators, if you're really looking at it from the quality of developer productivity or experience and all that, you can find that there are like some very specific DevOps metrics, like the base traditional metrics. Again, going back to the operational efficiency, I keep gravitating towards that because that is something that everybody can relate to and understands, right? So you have a production system, and you have significant amount of ticket volumes and SLA challenges and all that. So, one thing that you can really look for is like, what is that level of automation? What is that intervention effectiveness that is happening? And then by applying AI, you are able to handle some of these things automatically, right? I mean, so those autonomous agents, for example, can come in and solve a group of problems. So, for example, for Q1 or Q2 of this year, you ended up having 10,000 issues, for your large production system. And out of the 10,000 issues, if using AI, you can quickly categorize and say that, hey, using 80/20 rule, 80% of the tickets can be categorized into 15 different categories. And out of the 15 categories, you find that the top ones is taking about 50% of the tickets. So by addressing that, you are now able to reduce that ticket volume significantly. So there are techniques like that you can use by applying LLMs here. Hello, in a quick favor, if I may ask you, if you're finding this video helpful, please hit the like button and share with someone you might benefit. Maybe it's some colleague who's struggling to streamline CI/CD, or trying to introduce GenAI or Agentic AI or any of those things. So these people might be building an internal platform, or might be just trying to shift that security left or do some level of DevSecOps. So your share could be that nudge that they need to really move the needle and move it forward, right? So it sort of helps them also ensuring that they understand what the big picture of how all the platforms come together in an organization. But more than that, it can really help this particular channel so that we can keep creating more deeper and hands-on content like what you're watching today. Thank you. So so let's look at another tool, right? I mean, as I said, there are lots of tools within the space. One thing that would be really interesting to see is that how are some of these tools going to be helping you to tell the right kind of story with respect to what is actually happening, so that you can actually see what is happening within your system before you try and improve that. So for this, let me actually try and play this. Hopefully, this you can hear the audio. This dashboard is where we are capturing the intention of the cohort, whether they're focused on velocity, quality, or team health. And so we're filtering out all of the noise, if you will, which could be activity not focused on quality or not focused on velocity, depending on which cohort you're looking at here. And the goal of doing this is to get a clearer signal. Is the time savings that Copilot is providing helping people who are focusing on quality improve quality? And is that helping those focused on health and progress improving the health and progress of their team? And so we think this is going to be quite a significant improvement over what we're seeing most organizations doing with something like Metrics or even just sentiment surveys.
Because of the flexibility of the platform, we can meet you where you are. So for example, we can capture time saving based on surveys, but if your process is consistent enough, maybe we can capture it from, your Jira or your PR directly if you use a certain kind of process. The point is not necessarily how we capture the data, but the framework. And as Matt said, look, understand what the potential energy is, figure out what left to their own devices your folks are doing and how they're moving the needle locally. And then, with this and essentially the rest of Pharos, figure out how to harness that and transform your organization. All right. So the tool that you just looked at, Pharos, I'm sure you have heard of it. If not, definitely check it out. So this is a tool that actually provides a lot of information and data around problems like what's mentioned here, right? Things like if your Copilot adoption is suboptimal, which is something that you find all the time. Say that like, okay, why is that happening, and how can that be sort of improved over time? But for that you definitely need the data, and this is where that helps. Now let's moving on to we looked at how to actually figure some of these things out, right? We talked about value stream mapping, flow engineering, and looking at some of those things and applying that to some of those leading and lagging indicators and figuring out how some of the AI techniques can help you detect that and solve it and all that. So essentially that baselining part is something that now you have some idea of. So once you do that, the question now becomes like how to improve that overall developer experience through generative AI. So in that space, one thing that you should be really looking at is like some of those GenAI copilots, right? I mean, that sort of offer you more of that personalized guidance across onboarding, CI/CD config, and environment setup. So remember that the tasks that we are talking about are not just coding or debugging, right? And this is far more about that overall that engineering platform, the kind of things that traditional engineering platforms provide. So even for infrastructure code, you would find that inline code explanation remediation things can be very, very effective. And these things are, really available across the board in so many different tools. And those natural language interfaces to developer portals and documentations are making the platforms far more discoverable, right? So now, pretty much every backstage implementation that you look at, they will have some MCP servers and some kind of chatbots and things like that. That will ensure that you can actually easily talk to the set of documentation and everything, or access the documentation and the information that's available in the organization far more easily. And ultimately, I'm sure you heard of the context-aware aspects of the context-specific aspects of agentic AI today. But idea is that having those context-aware recommendations based on what your team has been doing, what your organization needs, makes a huge difference in the way you're solving these problems. So platform embedding and the GenAI fusion is another huge aspect you should be thinking about. By that, what I mean is that when you're using LLMs with some vector embeddings, and again, you can create some of those semantic search right across the platform services. So a simpler way to understand is that if you are really automating your environment, and can you actually do that using a very simple command like create a staging environment with Kafka and Redis, right? I mean, see, those are some of the very typical things. So once you do that, is there an easier way for you to actually get these things, make sure that these things are available across the organization, right? So that's where that semantic search part of it comes in. So where you can really think about it from the point of view of, hey, here is the functionality I need for my services, my platform services. If that's the functionality I need, how do I actually get that? Maybe somebody else has done it, so let's go out and figure out a way to get that in place. The other aspect of it is some of that intelligent platform feedback, right? So if you have AI agents, that can actually suggest faster workflows based on past usage patterns, that'll be phenomenal, right? Similarly, from the point of view of all that developer telemetry that we were talking about earlier, and can LLMs be used to summarize some of that so that you're not really looking at a humongous amount of data to solve the problems, but instead you're really looking at what is the easier way for you to really get an analysis or a high-level view of that. So another example we want to look at here, or an example tool that we want to look at here is the Pulumi Copilot. So Pulumi, as I talked about earlier, this is sort of like an infrastructure as code tool, something like a Terraform, but this is far more access for if you are more familiar with Python than anything else. Your barrier to entry is far more lower in that space. But so let's look at how infrastructure as code is being the process of IAC is being improved by using Pulumi Copilot.
Today we are excited to introduce Pulumi Copilot, the first AI intelligent cloud management. Pulumi Copilot is a new conversational chat interface available on every page of Pulumi Cloud. Pulumi Copilot combines the best generative AI models available today with the rich information available in Pulumi Cloud about all of your cloud infrastructure managed with Pulumi. Pulumi Copilot is powered by Pulumi's Cloud Supergraph, which includes information about every resource you are managing with Pulumi across any cloud, any account, and any region, across over 160 cloud and SaaS providers. On top of this, Pulumi Copilot has access to all of the stacks, projects, updates, deployments, environments, policies, audit logs, and more within Pulumi Cloud, enabling you to find, learn, and act on any cloud infrastructure. Pulumi Copilot is available within Pulumi Cloud. After enabling it for an organization, it can be found in the lower right of any page of the Pulumi Cloud console. We can open it and ask how it's doing. It knows who I am and greets me back. Through Pulumi Copilot, you can explore your cloud infrastructure and gain insights across an incredible breadth of use cases. We will dive into a few of these, but the possibilities are truly endless. In this first example, we can generate new infrastructure code inline inside Pulumi Copilot. We ask Copilot to deploy a serverless application on AWS, and we get a full program we can deploy directly with the Deploy with Pulumi button into our cloud account. We can also answer questions about our existing infrastructure. If I want to find out how many AWS Lambdas I am running in my organization, I can ask and get a count of resources. We can also take advantage of Pulumi's Copilot's knowledge of AWS best practice to suggest compliance guidance, even ahead of adopting more formal compliance tooling like Pulumi CrossGuard compliance-ready policies. As part of debugging tasks, we may need to get help to understand error message and how to mitigate them. In this example, we have a failing update action. Pulumi Copilot is able to analyze the failure and give a detailed feedback we can use to solve the error. Those were just a few examples of Pulumi Copilot in action, but there's so much more you can do and explore with Pulumi Copilot. Get started with Pulumi Copilot.
All right. So the purpose of showing these tools, once again, is not to recommend that you go use it, right? I'm sure all the vendors would want me to say that and want us to all go try it out. But it is to show like how are vendors thinking about these things? How are different tools being built around some of these ideas? And you can see that there is that significant amount of automation that is happening that is taking the abstraction level to a different level, right? I mean, so you're really trying to say that in the past you used to do things in certain ways, you used to troubleshoot your infrastructure as code in certain ways. Now let's do it in different way. Now are there ways in which you can really create or accelerate that IAC development? That is another thing that you could do, right? So I think those are the kind of things some of these tools are doing. So that's the reason why we wanted to show you this in the context of this presentation. Another example that we wanted you to look at was that this is a phenomenal open source tool called Robusta. So we wanted you to just take a look at this one to see like how does Robusta do like Kubernetes level RCS. So let's look at this one as the next example. Give me 1 second. Yes, we have here. Okay, so let's first look at how are they doing this automated root cause analysis. And again, you have the link now. You should be able to go in and take a look at this. The idea is that, again, remember that we are talking about that MTTR example earlier, right? So if you have that MTTR example, how do you actually go through the process of applying AI to some of these techniques and make sure that you get the right kind of outcome, which is obviously to reduce your MTTR.
Customers. In this video, I'm going to show you how you can do that process.
Sorry about that. Let me just start from the beginning again.
Here's a Prometheus alert. And when a Prometheus alert like this fires, my team needs to investigate these alerts and fix them before they impact our customers. In this video, I'm going to show you how you can do that process much faster using an AI assistant for Prometheus alerts in Holmes GPT. To get started, let me click on the root cause tab here. Whenever an alert comes in, Holmes GPT automatically takes the alert, gathers any relevant data, and then surfaces up the conclusions to me. In this case, it looks like there are image access issues, and there might be an authentication failure. Well, it's time to fix that. But how can I fix that problem even faster? Well, I'm just going to write a follow-up question, and I'm going to ask Holmes GPT to give me the remediation commands. And just like that, here are the commands to fix this exact problem. And I've shaved 30 minutes off of investigating and fixing this alert so that my team can go back to doing the work that matters without distractions.
Awesome. So as you can see, there are a lot more demos in here you might want to take a look at. And there's so many tools like that coming out, but we just wanted to call out some of these tools that you think, we think will be very valuable for you as you really go through your platform engineering journey. Hello, we would love to hear from you. If you got a question about anything that we have covered or maybe something that we only touched briefly and you wanted to learn more, please drop your thoughts and comments below. We are always reading and responding, so your questions often inspire future videos and episodes, either regarding this book or any other topic. So let's build a community of learners who can help each other grow in this fast-moving space. Thank you. So now, one other thing we want to sort of emphasize a little bit more is like, how is GenAI improving that observability space, right? And we are talking about a lot about this there is a section in the chapter 11 of the book about some of these things, right? So few things here. So AI enhanced observability patterns are something that is getting a lot of attention by pretty much every vendor that is actually playing in this observability space. So the few areas that you could say is that that summarization of alerts and activities around logs and traces, that becomes more actionable today. so that you don't really have to have another automation that you have to build, your platform engineering team or your SRE team would have to build. It is something that is available right out of the box. And then you can start seeing some challenges around. I mean, it has always been, there's been some challenges around like detecting those unseen failure patterns, right? I mean, so these things are now exposed far more easily. And the RCA, so we keep coming back to this, right? If you are, doing some level of, production support for a checkout system or something like that, I'm sure that the main checkout failures and things like that happens at 3 a.m. This literally happened a couple of months back for one of our clients who was like a huge grocery chain. So essentially, the failure did happen at 3 a.m. So I think, and we are helping them trying to improve some of these RCA activities using AI. But if we had really done some of these things, these classic problems like this would never happen, right? And then generating, once you do that, the next morning comes around, the day one, day two comes around, you're going to have like that auto-generated incident reports with those RAG workflows. And then you can actually train that on some of the run books that you already have in place. So you're not really reinventing the wheel, but instead just applying some of those intelligence, some of the data that you're getting on top of this. This is another illustration from the book, from the draft of the book. You can see that if you really look at the observability space, we would sort of classify that into 5 different categories, right? One is on the anomaly detection and RCA, which we spoke about. Then the other one is predictive analytics and some of the proactive remediation that you'd see. Then you'd also find some challenges around automated incident response and resolution. This is a huge, huge aspect. I gave an example of this earlier. Pretty much everybody is doing something around this space. Then security observability and threat detection, right? There's a lot of work happening within the space, and there are vendors who are providing these things, as well as automated log analytics and insights. So there are multiple tools and solutions that are happening through GenAI in all of these spaces. So now, sort of to close the loop on this in AI and observability, right? That event correlation is going to be super important, right? Because this is the area where the biggest challenge has been, right? If a problem happens, the idea of observability being that you're really ensuring that your production, your clients don't really see the problems before you, right? I mean, essentially, like you want to see the problems first so that your clients don't see it. So if you are doing it that way, one thing that is super important here is that time, right? You want to make sure that, because in some cases there is not enough time, there is, you really need to have that automated ways of fixing some of these things. So that event correlation becomes far more important. And LLMs are offering a lot more plain language dashboards, right? So that anybody who's actually helping support the system, whether it's in different part of the world with the different levels of technical competency and all that, or more junior folks, they're able to actually understand things because of the way LLMs can explain this. And like we saw in some of the examples earlier, like with Robusta and all that, so that Prometheus Grafana integrations with chat-based GenAI assistants are becoming a lot more easier for us to sort of understand and act on some of these things. And the main thing here is like, how can you actually train the systems using your own production data? This is where the RAGs would come in. So your production data is unique to you and what you're doing. And these systems are letting you do that. You train the LLMs with your production data so that you have increased levels of accuracy over time. And again, this is another thing that we are covering in the book, some of the ideas of how do you do RAG with prompting, right? Essentially, like, the idea is that if you have your own repository, your own ontologies, catalogs, and guidelines, you should be able to train the system in such a way that the LLMs can understand a lot more context of what is happening within the particular organization and particular problem domain that you have. So we would love for you to check this out in chapter 11 and understand a little bit more about this. So and since we talked a lot about the software operations and trying to understand, categorize tickets and solve it and all that, let's look at another product called Resolve.ai. This is a very popular product that is out there. And this will give you a pretty good overview of, it's a very quick overview of how automating software operations happens with this.
Introducing Resolve AI, your AI production software engineer.
Let's see it in action. Here I am getting paged at 3 a.m. about increased error responses from my service. By the time I get to my laptop, Resolve has already given me a hypothesis of what happened. My alert is being caused by a recent change in a downstream service, which is throwing null pointer exceptions and impacting my service. It even gives a recommendation to roll back that change to remediate the problem. Resolve has done a lot of work. It has a full understanding of my application. It's figured out that this error is impacting my users, and it's checked my downstream services that I rely on to see if they might be impacting me. And it's reconstructed the sequence of events that led up to the alert. Resolve understands my source code, and it detected a change in GitHub from 3 days ago that introduced a potential null pointer exception. The change was rolled out this morning, and it led to an increase in error responses from Prometheus and log errors in Loki, and is now impacting my service, leading to my alert firing. To get to the root cause, Resolve has built an agentic platform that is checked across all my different telemetry, source code, and infrastructure tools, just like I would do. And in less than 2 minutes, it's built and executed a few just-in-time runbooks to see what might be happening. And I can follow the remediation Resolve suggested and get my service back to healthy. And I get to go back to building. Or in this case, I'm going back to bed.
All right. So there are, I mean, so Resolve is a fairly popular tool, but as you can see, there are a lot of players who are actually working in the space. So that the landscape page that I showed you earlier is something that you might want to take a look at to if you are interested in solving some of these problems. So another tool, I know that we have covered a lot of tools. Another tool that there are, I think this is probably the last but one or something. So one other thing that I would like you to take a look at, since we looked at Resolve.ai, is Kubia.ai. So we have been looking, and I personally have been looking at Kubia for at least for a couple of years. This is a really powerful tool. So the way they actually started pitching this is like, hey, here is your AI for DevOps kind of thing. But what you're really now seeing is that that interaction is that human in the loop is significantly high within this Kubia, so that your level of confidence that you could gain out of your overall operational activities becomes significantly higher. So let's look at a quick demo, a 2-minute demo of this one.
Your AI teammates for developer and infrastructure operations. Free your time by delegating away your repetitive tasks. In the world of DevOps, every day is packed with repetitive tasks, managing deployments, monitoring systems, granting access, fixing bugs, and babysitting the on-call engineering channels. It's easy to get bogged down and feel overwhelmed. Meet Kubia teammates. With teammates, your world just got a whole lot simpler. They understand the context of your requests, orchestrate entire process end to end, and finally, action the request in a predictable, controllable, and repeatable manner with full oversight for you and your entire team. Delegation with Kubi is like having a knowledgeable teammate to take the work off your plate. Tasks like deploying code, monitoring system health, solving your engineering ticketing systems, and resolving incidents are now automated, allowing you to focus on more strategic work. Imagine transforming chaos into clarity, stress into efficiency, and backlogs of redundant work into strategic planning sessions. That's the power of delegating to Kubia teammates. Kubi assimilates itself into your organizational flow, integrating with your existing tools, processes, and knowledge, facilitating intelligent collaboration and productivity across your team. From automated alerts to performance monitoring and deployment management and incident response, Kubi handles it all through intelligent delegation of your organizational flows. Ready to transform your operational workflow? Experience the future of automation with Kubi. Start today and elevate your productivity. Delegation is the new form factor of automation, and Kubi makes it possible. Visit us at kubia.ai to learn more. Kubia, your AI teammate for infrastructure operation.
Awesome. So everything that you saw on Kubia is not everything is platform data related, right? I mean, there are a lot of productivity improvements and a lot of process improvements and all that. But what it really provides you is that level of maturity so that you can really now be creative enough to figure out the right kind of workflows that you need to bring in to ensure that the mundane tasks within the platform engineering space is sort of being automated, so that you are really going to focus on the most important things as a platform engineer to ensure this is your time is actually made as valuable as possible. So now let's spend some time also on the agentic AI side of things. I'm pretty sure by this time, all of you know what agentic AI is, but I'm going to give you a quick rundown overview of it and talk about like how is that impacting platform engineering, right? So a simple way to look at it, again, I'll refer back to our presentations 1 and 2, where we would be talking about some of the notional architectures and the scope of platform engineering itself. And that sort of in a diagram, that sort of comes into these first two zones, right? Your developer zone and the platform zone. So because developer zone is where you would have things like your developer portals ID, where developers sort of interact and interact with the system. And the platform zone is sort of required by the developer zone, right? So I think the things in platform zone are what we talked about as the scope of platform engineering, things like your observability, orchestration, CI/CD, cloud infrastructure, and all your runtime, security, all that kind of aspects would go in there. And what AI Zone literally does is that, by bringing in some of the agentic AI and the ideas around this, what this really does is that it sort of improves your platform zone, and it sort of is required. In order for you to do that, you really need your existing data, right? So without really understanding what agentic is, what AI is, and all that kind of, what MCP is and all that, just simple way to think about is that I have to improve the experience of the developers. I'm using platforms to do it. And AI sort of improves that. So that's the most simplest way to do it. And in order for AI to improve that, AI needs the data to do it. So now to define agentic AI in platform context, think of it like that autonomous systems that perceive, reason, and act with a goal-oriented approach. So you're not really trying to say that, hey, here is like an AI system that will actually give me some ideas to do it. No, this is going to act, right? This is not just perceiving, not just reasoning, but acting with a specific goal in mind. So unlike the Gen AI, what really happens in the agentic systems is that it sort of evolve the workflows. For example, if you have a CI pipeline, if you are going to have some infrastructure drifts and things like that, that needs to be shifted. Agents can actually come in and fix that for you. So, and in some cases, it can fix that, and you will know after it has been fixed that it's been fixed, right? So some of the agents that we have built are things around infrastructure remediation bots, and things like proactivity security, looking at how do I actually make sure that my agents are far more secure, or things like reinforcement learning with human feedback. And again, so essentially the idea being that you are using that human feedback to improve your decision quality over time, right? And this is how agentic AI would be far more acceptable to the industry and the people who are actually doing it. Otherwise, you're always going to have some level of skepticism saying that, is this actually going to be doing the right thing? And if it did the right thing, did it actually inform me? And was that the right thing to do? Why didn't I take a path B versus a path A kind of thing? So those things can be addressed by the RLHF. And impact of platform engineering, so the whole operating model is also starting to get impacted with agentic, right? So when AI came out, GenAI came out with the kind of impacts that it had for a couple of years back, the impact was not as much as what we are seeing with agentic. So the idea is that platform teams now shift from scripting tools to designing agent ecosystems, right? I mean, I think that's what they end up doing. And what you're finding is that you're having the questions like, can I optimize the cost of this application while maintaining the SLOs? So these things used to be far more complex to do in the past. Now you can let agents run that, and while it's monitoring the SLOs and making sure that those things are actually met, you're also trying to optimize cost at the same time, right? So you're not really thinking of these as an after the fact activity. So these cost improvements and the FinOps and all those things are becoming part of your platform itself. The other thing that you would find is that it sort of encourages the composability side of things, right? So agents can interact whether it is the DevX agent interacting with the cost optimizer agent, there is a lot of multiple agents sort of work together. It's not at any point of time one agent doing something. So this sort of creates this idea of composable architecture, composable operating model, which becomes one of the principles behind platform engineering. The idea becomes that platform becomes the brain, and the autonomous agents sort of evolve those platforms without manual configuration. So you have all the fundamentals sort of defined as part of your platform. Then the agents sort of work with those configurations and the data and the kind of context engineering that is happening, and then try and improve it. So now we talked about this slightly earlier, and I wanted to actually come back to this. So what you're really looking at is that if you are trying to use Agentic AI with the engineering platform, what is it that's giving us, right? So whenever we talk about bringing an engineering platform to any kind of an environment, first thing we do is some kind of a value stream mapping. We do the flow engineering steps within that. Then figure out, okay, where are the biggest problems? What are the biggest opportunities? What's the biggest bang for the buck? And with that, we are almost always able to, if you are working in an environment where there is significant amount of inefficiencies, you're able to improve things by 2 to 3x, right? Again, this is just a random number, but at the same time, so it's typically what we see, right? So there's significant improvements that you can bring to your overall developer experience and your overall, if you're doing value stream mapping, your reduction in your wait and work times. But by incorporating Agentic AI into engineering platforms, you're further able to cut the time by another 50% or so. And this is again contextually applied. So, but you have to really look at it on a specific case-by-case basis. So here are some examples that you look at, right? So let's look at maybe one of these examples again on the observability and incident response. So if you're using an engineering platform, what you're typically trying to do is that you're correlating a logs, metrics, traces, typical data that you have, and then doing some level of analysis and think about the actions that are needed. There are lots of tools available to do that, but at the end of the day, those actions are things that you end up doing yourself, right? So, but with Agentic AI, one thing that you would find is that you'll have that predictive anomaly detection happening, so that first of all, the incidents are not happening, right? Because you're not letting it happen. And because why is that not happening? Because agents are not doing this after the fact. Agents can proactively go in and remediate it before your client sees that, your customer sees that. I think that is where the real benefit would be, so that if you think about it from a value stream point of view, the amount of time saved, it becomes significantly far more achievable and interesting, and your platform engineers become the engineers who actually build some of these agents to be able to do that. So the other thing that we didn't talk about a lot, but something that would be really interesting is to really look at from a PRD point of view. So I think as you are really trying to create some of the platform capabilities, one thing that we always talk about is that one of the most important thing there is really to think about it from the point of view of how are you actually having your technical product management built into it. So the technical product management, it's almost always going to be like humans who are actually there. Sometimes you never have enough of it, because that becomes the most significant part of the concept of platform engineering. So what you end up doing in these cases is to sort of bring in some of these modern tools that can supplement the capabilities provided by your technical product management or the capacity of it. So one tool like that we'll look at is called chatprd.ai. And this is just from a demo point of view, and if you are interested, definitely check this out further. So what it does is that, let's say, in this first case, what I did was that I tried to provide some initial prompt. So I said that, create a PRD for an agent that will do a PR review. So as a platform engineer, one of the things that I want to do is I want to actually go in and create an agent that does a PR review. So before I end up doing that, I want to create a PRD. So what I ended up doing was that I basically asked that prompt here, and it has come back with essentially the right kind of questions. So the questions that it was asking is that, hey, who are the target users? What's the scope? What's the integration point? And do you want this to be an MVP with ambitious kind of thing, right? So based on that, I provided some inputs. I said that, hey, target users and internal developers of my team, building an agent, and then so and so. So I think I provided I wanted information around building an MVP. So what it did was it basically took all that information, then started creating an outline proposal for all of these things. Right? So once it actually did once it did that, you can really see that the overall the PRD was literally available for what I wanted to do. So essentially, for my company, it was saying that, hey, I'm building this MVP agent, um, for internal use that does whatever it needs to do, and then provide the goals and business goals and the user goals. So as you can see, like with just a couple of clicks, I was able to get started to be able to go build this one. But before I do that, I want to have the clear PRD and make sure that it sort of adds into it. So the idea is that these kinds of tools can literally accelerate the whole process. And in this case, I was using this in the context of platform engineering, but obviously I can use this for anything, right? This is not constrained to platform engineering. I can do this for anything. But some of these tools are extremely powerful and something that you should have in your toolkit as you're really building an engineering platform. One other, again, we want to go back to the Pharaoh's tool that we looked at earlier, Pharaoh's platform that we looked at earlier, and look at how some of these things are really helping you bring the transformation by summarizing all the tools that you have. Because you looked at so many different tools now and the impacts of all these tools on various things that you're doing, but how can you really get a overarching view of some of these things? So this is another demo from Pharaoh's, which you can take a look at. That'll actually help you do that.
The AI Transformation NJOPS module in Pharaoh's AI is designed to support a data-driven approach to the evaluation, rollout, and ROI extraction of new AI technology and software engineering. Today, top of mind are coding assistants like GitHub Copilot. Every module in Pharaoh's is customizable, but we've co-designed this one with GitHub to give you an excellent starting point. It combines survey data with systems data to provide a well-rounded view. Starting in the summary dashboard, this is where you can see the impact your adoption has had so far. How many developers are using it? How much time are you saving? And how that would translate to an economic benefit. Next, we have more detailed charts on adoption and usage over time and what Copilot is primarily being used for. And when it comes to time savings, you can see which activities are saving the most time and which teams are benefiting from it the most. Then you can see how the time savings are translating to velocity improvements in merge time and in lead times. And finally, you can understand how developers feel about the new technology with survey results here. In addition to observing the time savings from faster dev task completion time, as seen in the summary dashboard, a second dashboard allows you to perform cohort comparisons. This is where you can see something akin to an A/B test, comparing the metrics for a cohort augmented by Copilot with those that do not have Copilot, and you can see when the pilot began. Different teams will want to leverage the time savings towards different business outcomes or downstream impacts. In this example, we have 3 cohorts, each focusing on something different: velocity, quality, and health and progress. Looking at the velocity-focused cohort, we can see that indeed, since the pilot began, lead times have improved for the Copilot augmented cohort. This approach helps organizations be intentional with how they redeploy resources or capacity to achieve very specific and long-awaited improvements.
All right. This is there are other tools like this, but Pharaoh's is one tool that I like a lot, that actually helps you provide this kind of summary information, right? Because ultimately it's all about the outcomes that you want to generate out of all the tools and the systems and the new techniques that you're using with AI. And this provides you that a really nice, easy to understand way of articulating some of these things. Also think of tools like Pharaoh's as a framework in which you can actually define a lot of your own metrics too, right? It's not about like they come out with all these out of the box metrics, and that's all you have. So I think that's another good reason to be using some of these tools. Hey, there is more content coming up soon, and you don't want to miss it, right? In the next set of videos that might be coming up later, you might find other things related to engineering platform, as well as some of the transformation activities. So you should definitely hit the subscribe button and hit the bell icon so you can stay ahead of the curve and think about all the cool videos this channel is going to provide. Thank you. So as we try and conclude this one, so you also have to think about, like, as you're bringing in some of these tools, what are the key things to your adoption, right? I mean, so I think as long as you can really align, which is the point that we were making in the previous slide, as long as you can align whatever you're bringing in from applying AI to platform engineering, as long as it can be aligned to those whatever the developers need, this is actually going to be working, right? Because that's something that's needed. You don't really need to have, like, random bots doing XYZ, right? Just because somebody else does that, just because there is a tool that you found that looks cool, doesn't mean that that's something that you need. So the second thing is that you should always optimize for flow, not features. I would again urge you to really look at the flow engineering concepts if you have not done that. This is the idea where you're really trying to make sure that one specific features are less important as opposed to the overall seamless flow of what is happening within your overall workflow. The third one is make sure that these agents are more collaborative, right? So you always need to have a human in the loop. I'm still not personally not sold on the fact that you can just let some of these run amok and then just make sure that we just accept it, right? So we should let the agents propose, because they would probably have a lot more information to propose some of these things. But let's make sure that your stakeholders validate what their really agent is proposing. And observability one, we want to explicitly call out, because like we spent some time today, this is something that is going to be hugely impactful. And that impact would be one of the reasons why you might want to bring the whole AI augmentation right off the bat. Ultimately, right, just like we talked about aligning to developer work streams, make sure that measure the business impact. Use whatever the tools, like Pharaohs is one tool that you saw, but use whatever tool that you have in your organization, or find some tools that's out there. Make sure that look at the business impact, look at the data, right? I mean, so it's not about the model metrics, and it's all about ensuring that you are getting what you need out of it. So that is the primary keys to the whole adoption here. So if you want to learn more about it, we would definitely urge you to take a look at the book, and the discount code for the book is there in the description. You might want to grab a copy today. It's been in the early access for several months, and the print version should be coming out any day now. So thank you so much. This would be again the fifth of the 5 different presentations that we are doing, and really appreciate your time. And if you want to check out effectiveplatformengineering.com, you can find information about all of us others and what we are actually doing within the space. So thank you so much, and we'll see you later. Bye.